Hi all, welcome back. This is Param. In this episode, let us see at the high level knowledge of Terraform. Okay, Terraform is one of the way to programmatically work with the Google Cloud. Not only Google Cloud, it can work with any other cloud. So the purpose of Terraform is only for provisioning, not for configuration. If you need configuration, better consider Ansible tool. Okay. I think I can go one by one instead of looking for specific order. Sorry. Provider. So provider is very important. So it is basically Terraform plugin based architecture. Okay. So whoever want to extend Terraform functionality, so they can extend. In that case, Google, AWS, Terraform, anytime. Okay, yeah, fine. Okay, so even Azure also have that. Okay, so they are providing one provider. I mean, they are giving provider implementation for the Terraforms. Okay, it has registry. Okay, it has registry. Registry is kind of central place for keeping all the modules or reusable components. Okay, reusable modules are kept in the registry, so you can refer that registry. So while doing initialize command, it will download all the dependencies, all the dependencies or modules which is defined in the registry. Okay, so from the registry can be anything. Okay, even any version control also can act as a registry, or any URLs or Terraform registry. In fact, Terraform cloud. Okay, all these things can be act as a registry. So they are providing version SLs. Okay, then while writing writing Terraforms, so it is kind of based, it is syntax similar to the JSON. Okay, so curly braces will be there, then key value pair will be there, instead of colon equal symbol will be there. Okay, the basically each file, configuration files can have multiple blocks. So blocks is a kind of unit of configuration. Okay, I can say it's a unit of configurations. So here we can see a couple of the blocks. Module is one of the block to consume other modules. Okay, resources, it is this block type define the resources. Provider, it declares the who is the providing implementation of Terraform. Okay, for set of the block type. Output is you can create the output of any variables or links, something like that. So in let's say in Google Cloud, it creates several objects. Okay, so if you want to know idea of any one of the object, you can use the output. Variable is kind of input variables. Okay, variables kind of inputs in input variables. So you can define the data type, description, and the default values. Okay, for each module, a set of variable can be input. Similarly, set of variable can be output. Okay, these are the block types. We have to be familiar with that. That's how we write the Terraform configuration files. Okay, workflow. Okay, so workflow, what are the steps? That's it. Okay, what are the steps are there to create a Terraform? First things, we should know the scope. For scope, in the sense, what is the exact requirement? Okay, scope is what is the exact requirements. Then author phase, steps or phase. So there we are going to create all the configuration files. I'll tell you that we'll explain module. I'll explain what are the files are there. Then init phase, we will download all the dependencies. Then plan. So it's kind of what are the resources going to be executed. Plan is kind of execution plan in set of SQL tools. Okay, in SQL tools, if you write any SQL query, they will say what are the tables going to fetch, when the join is happening. So all the steps you can understand how the query is being executed by database engine. Okay, similarly the plan is Terraform plan. Terraform applies actual things. It create the resources in the infrastructure. Okay, or it create the infrastructure. Okay, that is what workflow of the things. Here as I said, here is the execution plan. Execution plan, we can do that Terraform space plan, that is a command. Okay, and you can save the state, you can save the plan as well. In fact, you can reuse that plan while executing apply. Okay. As I said, variables. Okay, variables, we have variables. Okay, variables. Okay, then this must be a plural. Variables. Okay. Variable.tf files, it is one of the configuration files. So there only we will declare all the variables. Variables.tf var is the runtime actually. Okay, when we execute, we will pass the values for the variables. Okay, so instead of typing every time, so you can keep all those values in this file, and it will pick up automatically. Okay, that is the benefit. So otherwise what will happen, whatever the variables we have defined, we have to assign the values. So every time we are going to execute, it will ask value for that. Okay, but if you created a file called variables.tfr, then it from that variable, from that files, it will take a value for each variables. Okay. Outputs, as I said, if you want to know output of some of the ID or important information about the resources, you can use output. It's again another configuration files. There we will use the output block, and there we will declare the variables. Okay, so that's how your information about the infrastructure will be printed on the screen. Okay. Caching the attribute resource. What I mean by caching? Yeah. Okay, so what is now while running, okay, it do the caching for the set of variables. Okay, so that it will reuse fast or something like that they are saying, but it do the caching. Okay, do the caching of the attributes of the variable, attributes of the object, or attributes of the resource, something like that. Okay. Then Terraform state. Terraform state, it can be local state, okay, or it can be remote state. So local state is a default one. What it will store? Okay, so while executing plan, you can get the plan, right? But state, what is now? State, it will store the set of information about the resources it has been created, or it has been allocated, or it has been created in the cloud. Okay, so all the what are the resources has been created, those ID and set of information in the set of metadata information, that is called that dependency graph. Okay, all those information will be saved. Okay, so the second thing is what is it will if you do modification in your cluster by any other way, kind of like console or some command prompt or something. Okay, those changes will not be persist in the state at that point, right? So that's how we can make sure comparison. Whatever in the configuration is equal to the real resources available in the cloud. Okay, but if you do modification on the cloud directly, that times you have to do refresh, Terraform refresh. Terraform refresh. Okay. Similarly, if you want to see content of the state, you can issue the command Terraform show. Okay, then similarly you can from local to remote, or remote to local, if you want to move the state. Let's say I keep all the state in my local, but assume that some couple of other people also going to work in the same project, then state should be in a centralized place, right? Okay, so in that case, so how do I migrate? How do I migrate my from local to centralized one, so that other developers can access? For example, I can use as a backend GitHub repository, Terraform cloud, but mostly packets, Google Cloud packet. Okay, there a migration state can be migrated. So that is what Terraform init migrate state. In this statement, what is now, it's going to migrate the state file content from the local machine to remote, or remote to local. Okay. Okay, that is what local state here. Remote, as I said, remote logging is there. Remote logging, without remote logging, if parallelly many people works, there will be conflict, right? So to avoid that only, remote logging is there. Okay. So in fact, if you want logging need or not, using a -log, you can disable. Okay. So Terraform Cloud can be act as a remote store. Bucket storage, in fact, okay, stores metadata as well. Metadata is kind of a dependency graph, all stuff. Okay, syncing is there. The primary purpose of, yeah, there is exact definitions. Okay, static file also can be, yes, state file, state file can be versioned. This is another beauty. Like Terraform files can be versionized. Similarly, state file also can be versionized in GitHub or something like that. Okay. Now the exact simple definition of state. The primary purpose of the Terraform state is to build the binding between objects in the remote system and the resource instance declared in your configuration. That's what. So whatever we define in the configuration should exactly match with the real object or real resources in the cloud. Okay. Now dependency. Before dependency, let's come. Dependency can be implicit or explicit. Okay, so to understand the dependency, you can issue the command terraform.graph. Okay, and show dependency among the resources. Okay, dependency graph. What is a dependency? Basically, I think I have declared somewhere else or not. No. Then let me add here. There is implicit as well as explicit. Implicit and explicit dependency among the blocks. Okay, so what do you mean by implicit? Let's say if you want to create a virtual machine, okay, virtual machines, you need a network, right? So if you specify that network link within the virtual machine definition block, what will happen? So by default it will understand, okay, to create the virtual machine, network block has to be executed before. Okay, so without network we cannot create it cannot create the virtual machine, right? So in that case, that is called implicit. Okay, but what is explicit? For explicit we use the word like property or argument depends on. Okay, it can have array. Okay, what it will say now? Let's say if I want to create a storage bucket before creating the virtual machine, or in a reverse way, once the virtual machine is created, the bucket has to be created. So there is no relation between this and the bucket and the virtual machine. But if we want to have such a order thing, then that time we will go for external dependencies. Okay, that is what resource graph or dependency talks about. State registry modules. Okay, here. Okay, modules, any typical modules will have a couple of files. Let's say if I have if I want to have or if I want to have reusable modules, but the primary purpose is reusability. Okay, and so that maintenance is easy, there is no duplicate or repeated code. Okay, so for any module definitions, definitely we will have one Terraform files that are usually main or instance. If it is instance.tf files, if it is a bucket, then bucket.tf files. Okay, so all the parameters will be sent to that. It will create the object, it will create the respective resources. Okay, so any modules will be within the folder itself. Okay, so there is a child module if it is the case, then root module. The root module we will have the, I think I can explain here itself. Okay, root module. Say, let's say, so this is the challenge lab, which is a module. Here you can see the two files, main and variable start files. Okay, these two files are available in the root module, but the modules is a sub modules here. It has again two more sub module. Okay, so within that you can see storage is it going to have all the important configuration. They can input and variable start files to pass the variable to and into and by output. Okay, so this is what modules. So we as I said, root module and child modules. Module can be local module or remote modules. Yes, local module, since whatever I shown, it is local module. Remote module means it will comes from the registry. Okay. Okay, Terraform module similar to that concept like libraries, packages, modules, other programming language, or I would say it's kind of function. In any programming language, we can define as a function, and wherever we need, we can call. We can, for a function, we can send the value, send the parameter, and return the value. Same case here also. Okay. Okay, register resource or local path. Okay, so that is what modules. So definitely, even if it is simple configuration, there will be a module. So module makes reusable, maintenance easy maintenance. Okay. Okay, provider I have explained. Dependency, yes. Graph, okay. Here you can see that implicit and explicit. Okay, I think then I can delete from here. Delete. Okay, resource graph. Okay, dependency. Let me go. Okay, now it is apt place. Dependency. Okay, so it's explicit, implicit. So resource graph, it is a command to show the dependencies. Okay, which block dependence, which block other blocks. Okay, this side I have explained everything. Let me go here. Import module from the existing infrastructure. Yeah, what does it mean? Let me add the command Terraform import. Okay, so let's say you have resource. Okay, you have resource in your cluster or Google Cloud. Now you want create the Terraform configuration for all existing resources or already created resources, so that both will be sync, right? Okay, so I can do, say for example, for time being I am using console and creating couple of objects or couple of resources. Okay, so I want to be sync with I want sync with Terraform configuration files. So in that case it's obvious. Okay, for the situation we will use the Terraform import. Okay, block type I already explained. Now caching. Okay, provisioners, I'm not good. Okay, so I don't, let me not test the infrastructure. See, very simple. So far we have used init, apply, refresh, what else, import something. Okay, what is a destroy? Destroy in the sense it going to delete the object. Okay, it's going to delete the whatever the object defined in the files. It's going to, instead of create, it will delete. That is what destroy. Okay. Okay, so that it will clean the cloud. Okay, I think I have explained this also. Plugin architecture, yes, it's completely designed plugin architecture. Okay, I think I can show some of the things here. Okay, so this is one of the workspace. What is workspace? Yeah, this folder is workspace. Okay, so within the workspace only root files will be there. So within the workspace, root module files are there, and one or more sub modules are there, or zero or more. Let's say zero or more sub modules is there. Here you can, let's say, VM creation. VM creation is a workspace, so it has only main Terraform files. It does not have any modules. Okay. I similarly provider. Yes, I have only so provider only is a folder name. This folder is called workspace. Terraform workspace. Within that we can have the main root files. Similarly, I think, okay, yeah, here you can see the both. Here you can see the root module files are there, as well as sub module. Here instance sub module files are also there. Okay, that's what. Okay, so you can have your sample files, so that it will be easy to refresh or recollect whenever you need, or actual work is going on. Okay. Okay, I think that's all about the that's all about the Terraforms. Okay, Terraform, as I said, Terraform is one of the programmatic way to work with GCP at least. Thank you. Thanks for watching.